The longer we go on in this pandemic and I look at the outcomes that are occurring, the more concerned I get. I will prepare you that what I'm going to be saying next is not going to be easy to understand, and it may sound conspiratorial, but there is evidence that's coming out that is very, very concerning. And I'm going to give you a preparation for it because coming up in the next few days, I'm going to be speaking in a little bit more detail about this. This is an important point. This presentation was triggered because of some information coming out of Oregon about mad cow or prion disease, CJD. And I've been thinking about speaking about that for some time, but because it's one of those topics that you have to be careful about speaking about, I'd left it alone. And just so you have a full disclosure on this point, this is the fact check on it. COVID-19 vaccines are not associated with developing neurodegenerative diseases, and there is no credible evidence of any association. One of the problems when this is done is because I know that they haven't actually been actively looking for any research. It then becomes just a statement of if you think this is so, prove it. The problem they've got is that essentially there are scientists who will do exactly that. And you have to give credit to these scientists when it comes to understanding and challenging these principles. And this scientist in question is Kevin McCairn, and he is based, I think, in Japan. And what he did is he took a detailed analysis of the embalmer's clots. Well, let me just be clear, if you've not heard about that yet, that is another one of those strange things that people have been just saying is a conspiracy since 2021. Believe me, they're real. What has not been done is active research into it. Kevin now has taken it a step further. I've been following this now for over 2 years, and they have found that it has unusual characteristics with regards to the proteins and so on. But Kevin has taken this a bit further, and he's asked some very specific questions when looking at the clots. Now, this is linking in to what I'm speaking about soon, so you have to stay with me on this. So, what he found when he looked at this, and if you want to see this, I'm sure I'll put it up on my Substack. But what he did is that he was looking specifically for amyloid and prions within the clots. And based on the spectroscopy that he did, the Raman spectroscopy, it was over almost 85 to 90% confident. This was another assay that they look at for prions, and that was almost over 90% confidence that this was so. So, in effect, they are finding evidence that there seem to be prion particles within these clots. Okay. Now, the part of the problem is that people don't really know what are prions. And the truth is I had to sit down and process this over and over again because it's not a common thing to come across. And I'm going to try and explain very simply, but to get the full thing, you need to join me at the presentation. The link is in the description. A little bit about what is a prion disease. And usually what we're talking about is CJD, Creutzfeldt-Jakob disease, or the original form was scrapie, which would affect sheep. And this is over 250 years old. So it's not a new disease, but it's a new disease to humans. And what then happened is that you just have to understand a little bit about what really is going on when they talk about prions, because they are described as infectious proteins. Remember, I didn't say it was a virus, didn't say it was a bacteria. It's just a protein. And this protein is infectious. And we have known this for some time. And I have here, before I give you the explanation, I have a paper. This was from 2017. And in this paper, they were just looking, this is from Yasushi Iwasaki, and they were just looking at the fundamentals of this of the CJD, and he was pointing out that the prion came about in 1982, and it's a proteinaceous infectious particle. It's not common, approximately 1 to 2 per million. It can be sporadic, acquired, or infectious. And Creutzfeldt-Jakob disease is the most common human prion disease worldwide. Okay? It's very aggressive dementia. And the point about it is that it causes spongiform changes. So I'll give you a little bit of insight into some of those points. So let's start with just some basic stuff here. Prions are normal proteins. They are part of your body. They are unusually synapses, so they're connected with neurons. And this is kind of like an example of a prion. This is taken from a new take on prion protein dynamics and cellular trafficking. And this is it on the surface. And what can then happen is prions then get endocytosed, but if they get in contact with an infectious prion like this, it converts this into this. Okay? It's a difficult concept to get, and I'm going to try and see if I can get you to understand this. So this is the infectious prion, and it turns this normal prion into an infectious prion. Okay? That's the concept. And the best way that I had to describe that is kind of like what happens with strawberries. You have one bad strawberry. If you put it with good strawberries, even if they are not going to be spoiled, very quickly, they all spoil together. And that's very similar to how these prions work. Once in contact with other similar type proteins, it will then cause changes in them that make them also infectious. And when we speak about what happens in terms of scrapie, they would have had contaminated meat, say, for instance, or the grass. I can't even remember exactly where the sheep would have gotten it from, but it gets into their GI tract. And then what happens is that this here would represent the prions in their GI tract. It would then cross through the epithelium in the gut, and then it would interact with the neurons. And so this is the terminal end of, say, the vagus nerve. And as I showed you, is that it would then get taken up into these nerves and then gradually head up to the brain. And they travel slowly, say about 1 millimeter a day. So this is part of the reason why there is a time delay between the exposure and the onset of symptoms. And this is what would happen, with, say, with mad cow disease. Very, they would then get into the nervous system and get up to the brain. And the reason why they call it a spongiform disease is because of how the brain looks by the time the damage has been done. Here is another way that I describe these prions. It's almost like magnets. If you imagine this is a magnet here, these are all nuts and bolts. If you put the magnet on one of them, this bolt becomes magnetized and then attracts other bolts to it. And then the whole structure would then be built up in this way. And this is how prions work. And so, therefore, once they start coming in contact with each other, they then start to build up these structures that will do damage to the brain. And the damage that is done to the brain makes it look like a sponge in terms of pathology. And so I've got here an image so you understand. This is a sponge. This is what it looks like. And if you close up the sponge here, you will notice all these holes in it. And that's effectively what happens to the brain in CJD, because the prions then accumulate and then make holes in the brain. And so you end up with a sponge like looking brain. And that's the characteristic of the prions. And it primarily occurs in the brain because that's where a lot of these prions are located in terms of synapses. And this is therefore the pathology where you can see stage 1, small amount of holes. By the time you've reached to stage 6 here, you see these big holes, and therefore this is why it would look like a sponge. This is pretty serious stuff because we have no treatment for it by the time that it presents. But as I said, just giving you an insight, I'll have to be able to go into it in some more detail in the presentation. So if you want to understand more about this, if you find this fascinating, you then join me, because I'm going to be looking at whether or not some of the characteristics around the spike protein can also have prion-like capabilities. That's really the question. And if it does, how would it present? So that's my side of the question. So people like Kevin McCairn has done the hard work of proving that this looks like prions. And so for the scientific community out there who would say, I don't believe that, you need to get some embalmer's clots. You need to apply the same techniques that he used. And if when you've done it, you don't see amyloid accumulation and prions, then you can talk. But up till that point, there is nothing to say because only he has done this research. And we appreciate that he has done it, and the people who are supporting him to do this research, because this is not cheap. This is very expensive stuff. And this is probably why it hasn't been done before. So this, as I said, is an insight into the presentation coming up. This is a very serious issue, not something that we should treat very lightly. There's a lot more research to be done. And yes, although it sounds like a conspiracy, you almost wish it was, because the implications are very, very serious if this continues to become disease presentation. Have a great evening. Thank you.